Hi, in this video we are going to study how to convert numbers from one number system to another number system. So we're going to study how to convert from non-decimal to decimal, how to convert from decimal to non-decimal, and to convert from one non-decimal to another type of non-decimal. From non-decimal to decimal, which we have actually studied before, because we know how to calculate the real value of a number system. So if the number is not a decimal number, so we can use the same approach, which is called the spread number, to convert the number into decimal. So let's first look at the binary. So suppose we have this number, which is a binary number, and how are we going to convert into decimal? We use the spread number. So we calculate the power for every position. So we have 1, 0, 0, 1, 0, 1, 1. So we are going to calculate the power for each of the number. So the power will be, 1 for the rightmost bit, because the power starts from 1. Okay, and the second one means 2. Okay, because this is the power. And third number means 4, because this is 2 to the second power. Okay, and then it's 8, 16, 32, 64. So these are the powers of the number. And then we can use the power to multiply the digit. We have 1 times this power plus 0 times this one, and then also 0. So we are going to remove this 2 and remove this one because it equals to 0, and then eventually you get 75. So this is the decimal value of this binary number, which is also the number's real value. Suppose we have this decimal fraction number 0.1010 in binary. Again, we are going to calculate the power for each of the number. So the power starts from -1 and then -4. So the first power for the digit is 2 to the -1's power, so which is 0.5. And then the second one is 0.25. And then we can use the same approach to calculate the real value. So the real value of this number is 1 times 2 to the -1's power plus 0 plus 1 times 2 to the -3's power plus 0. The value will be 0.62510. Converting from octal to decimal is similar. We still use the same approach, use the spread number approach. So suppose we have this number 375.42 in octal. We're going to convert into decimal. So again, we are going to calculate the power of each of the position. So for the number 5, the power will be 1. For number 7, the power will be 8. And then we look at the fractional part. So for number 4, the power will be 8 to the -1's power. And for number 2, the power will be 8 to the -2's power. So we have this equation. We can calculate the real value of this number. So which will be this number. So we're going to get the sum of these numbers. So the real value will be 253.53 in decimal. From hexadecimal to decimal, still use the same approach. We just need to change the base. So this will be the equation for us to calculate the real value of this hexadecimal number. Because A represents 10, B represents 11, C represents 12, and then D is 13, and E is 14. So we're going to calculate the power for each of the position. So this will be the real value of this number. Now let's look at how to convert from decimal to non-decimal. This will be a little bit complicated. Let's look at from decimal to binary first. Suppose we have this decimal number, and what will be the binary representation of this number? If the decimal number is an integer number, we're going to use this way. So the number is divided by 2, and the remainders arranged in the reverse order. For example, we have 75 in decimal, and then we divide it by 2. So we got 37 for the result, and 1 is the remainder. And then we're going to divide this number again. So 37 divided by 2, we got 18, and the remainder is still 1. And then we divide by 2 again. So we got 9, and the remainder is 0. And 9 divided by 2, we got 4. Again, 4 divided by 2, we got 2. 2 divided by 2, we got 1, and the remainder is 0. 1 divided by 2, the value is 0, and the remainder is 1. And then we finish because the result is 0. So we have a group of remainders, and we are going to arrange the remainders in the reverse order, meaning that the last get remainder will put in the front. So this will be the order of the remainders. So the number in binary will be 1001011. Okay, so this is the binary representation of this decimal number. If you want to verify whether this value is correct, you can also try to convert the binary into decimal again using the spread number approach, and then you can get 75 in decimal. Because all of the decimal integer can be divided by 2 perfectly, so all of them can be converted to binary exactly. For the fractional part is different. We are going to multiply the fractional part with 2, and then we are going to arrange the integer part in the same order as we get it. For example, we have 0.6531 in decimal, and then we are going to multiply this number with 2. So we get 1.3062, and the integer part is 1. So we are going to remove the integer part and then multiply by 2 again. So 0.3062 times 2, we got 0.6124. So the integer part is 0. So we got 0. And then we multiply 2. Okay, so we get 1.2248. So the integer part is 1. And then we have 0.2248 multiplied by 2. We got 0.4492, and the integer part is 0. So we can do it again and again. So some of the numbers we can get the eventually integer, but some of the numbers we cannot finish this process actually. So we are going to arrange the integer part in the same order as we get the numbers. So this number in binary will be 10100. So this is not exactly equals to this number. So this binary number is only approximately equals to this decimal number. If we need a more accurate number, we need to keep more digits of the binary number. So in general, decimal fraction cannot be converted to binary exactly. Now let's look at this example to convert 49.58 in decimal into binary. So we have the fractional part, which is 0.58, and then we times 2, we got 1.16, times 2 again, we got 0.32, we times 2, we got 0.64. We can do it again and again. And then the fractional part in binary will be 100, and next number will be 1, but we only keep 3 digits for now. For the integer part, the number will be divided by 2. So 49 divided by 2, we got 24, and the remainder is 1, and then we divide by 2 again. So we're doing this again and again. Eventually, we got 110001. From decimal to octal will be quite similar as the approach we use to convert from decimal to binary. What we need to do is just change the base. So for the integer part, the number will be divided by 8, not by 2, because the base is 8 in octal. And then we use the same approach to arrange the remainders. For the fractional part, we multiply by 8, and then we arrange the integer part in the same order. So suppose we have this number in decimal, and then we are going to convert into octal. So for the integer part, we divide this number by 8. So we get 375 for the integer part. For the fractional part, we multiply by 8, and then we get this integer parts. So the eventual number in octal will be 375.42. From decimal to hexadecimal is similar. We just change the base to 16. That's what we need to do. So now let's look at from one non-decimal to another non-decimal. For example, from binary to octal. For example, we have this number 10.111011.1101 in binary, and then we are going to convert to octal. This will be quite different from the previous approaches because there are some special relationship between binary and octal. Because 2 to the third power of 2 equals to 8. So we have this relationship. So we're going to use a different way to convert from binary to octal and vice versa. Let's start from the integer part. We're going to split the number into groups of 3 digits. So the first group, we always start from the vertex point. Okay, so the first group will be 0, 1, 1, and the second group will be 1, 1, 1, and the third group, because we only have 2 numbers left, but we have to make it a complete team to have 3 digits. So we are going to add 1 digit that will not change the value of the original number. So we can only put a 0 here. Okay. So the first group is 3, the second group is 7, and the third group is 2. And for the fractional part, we use the same approach. We also split the number into groups of 3 digits, but because this is the fractional part, we are going to split the groups from left to right. Okay, so this will be the first group. And for the second group, we have to make it 3 digits, and currently we only have 1 digit left. We have to make it 3. So we are going to add some zeros, but without changing the value of the number. Of course, we cannot put numbers in front of this 1, because suppose we have 1 0 here, the value of this number will be changed. So we cannot put zeros in front of 1. So we can only put zeros after this one because no matter how many zeros we have after this one, the value will be still the same. So the next group will be 1, 0, 0. Okay, so the number for this group is, because this is 2, this is 4, and then the number is 6. And the next group will be, this is 1, this is 2, this is 4. So the number for this group will be 4. So the number in octal is 273.64. From octal to binary, we use the same approach, but because one octal number actually represents 3 binary numbers. So suppose we have this one, we're going to convert one by one. So we also start from the radix point. Okay, so the first number is 4. So 4 will be 100 in binary. And the second will be 5. 5 in binary will be 101. Okay, and 7 in binary will be 111. Okay, 6 in binary will be 110. So this will be the integer part for the binary number. And for the fractional part, the first digit is 3, which will be 011. Okay, and second number is 2, which will be 010. Okay, so we have the binary number. So the key point for this approach is that we're going to make groups of 3 binary numbers, binary digits, and we're going to convert each group. So if the group doesn't have 3 digits, we're going to fill the group with zeros. But remember, don't change the value of the original number. So you need to pay attention on the position of the zeros where you're going to put. From binary to hexadecimal, it's quite similar as the relationship between binary and octal, because 2 to the 4th power is actually 16. So for this time, we are going to make the groups of 4 digits. We start from the radix point, and then we make groups. This will be the first group, second group, third group. This will be the first group and second group. So after we calculate, we got BE6 for the integer part, and we got D and 8 for the fractional part. From hexadecimal to binary, each of the digits in hexadecimal represents 4 binary digits. So 8 is 1000. B is 11. 7 will be 0111. A will be 1010. For the fractional part, C will be 1100. 9 will be 1001. So this will be the binary number for this hexadecimal number. So the difference is that each of the group will have 4 binary digits. So how are we going to convert from octal to hexadecimal or from hexadecimal to octal? So what we can do is to convert from octal to binary first, and then we regroup the digits, and then we convert from binary to hexadecimal.